Question 3, let's find out what f dashed of x is. F dashed of x is 6x squared minus 22x plus 20, and that's all. That's all we've got to do. Find the values of x for which when that is decreasing. So if it's decreasing, then its gradient is negative. So we would want this to be less than 0. Well, that's a nice little quadratic, isn't it? That's a nice little quadratic. Should we divide it all by 2? Let's divide it all by 2. And if you want to grab your calculator now, do so. See if I can do it before you've grabbed your calculator. I've got 3x and x. 10 has got to be a 5 and a 2, hasn't it? Let's put the 5 and the 2 that way round. They both got to be negative. And so I've got interesting points at x is equal to 2, or when x is equal to 5/3. We want this quadratic to be less than 0. So if it's less than 0, it's between the 2 points there. So I've got x is between those 2 points there. For those values there, then I think it is decreasing. Should we grab the calculator and see how we do it on that? Because we do have a nice new inequality solver here. It's a degree 2, isn't it? And we want this quadratic to be less than 0. So I'm just looking at that thing there. So less than 0, so that's number 2 here. And the values I put in were 6, minus 22, and 20. And it tells us that x is between 5/3 and 2, just like we did with the algebra. So it's nice to check on the calculator. Part C then. Part C has got something slightly different. It's a different cubic this time, and we're being asked to show that this never decreases. Well, if it's talking about decreasing, I know we're going to have to differentiate this thing. And if it never decreases, I suppose that thing can never be negative, can it? Why can that thing never be negative? Let's take that factor of 3 out of it. And let's try and factorize that. That's x minus 3 times by... Hey, there we go. So if you use the calculator to do this, you'd never have spotted that this part here is x minus 3 all squared. Now, x minus 3 all squared must be greater than or equal to 0. It can't be negative. Something squared can't be negative. So therefore, f dashed of x is definitely greater than or equal to 0. So if it's always, well, it's never negative, is it? It's never negative. So that thing never decreases. It's never decreasing, therefore f of x is never decreasing, because the gradient could never be negative. The lowest it could be is 0, but otherwise it will be going up.